The year is 1988. A crowd of very important people with very serious faces has gathered in the Mojave Desert to see a secret. After decades of whispers and black-budget rumors, a hangar door slowly slides open and a shape begins to roll out into the California sun. But it's wrong. It's all wrong. There's no body. There's no tail. There are no distinct engines hanging off the wings. It's just a wing. A massive, boomerang-shaped wedge of black, a flying shape that seems to defy a century of what a plane is supposed to look like. It looks less like a machine and more like a shadow that is somehow solidified and peeled itself off the ground. This was the world's first look at the B-2 Spirit. Our story begins, as so many of these ridiculously ambitious military stories do, not with a brilliant success, but with a spectacular, humiliating failure. It begins in the dark, in another desert, half a world away. It begins with fire, sand, and 8 dead servicemen. It begins with Operation Eagle Claw. In 1980, the United States was in the grip of the Iran hostage crisis. Frustrated by diplomatic failures, President Jimmy Carter authorized a high-risk, complex mission to sneak into Iran and rescue 52 American hostages. The plan was a multi-stage affair involving helicopters, transport planes, and special forces, all converging at a secret rendezvous point deep in the Iranian desert, codenamed Desert 1. It was a disaster. A sudden sandstorm, multiple helicopter mechanical failures, and a tragic ground collision between a helicopter and a C-130 transport plane turned the rescue mission into a national embarrassment. The failure at Desert 1 sent a shockwave through the Pentagon. It was a brutal lesson. It proved that the United States military, for all its might, could no longer guarantee that it could get in and out of a hostile country undetected. Their conventional forces were loud, visible, and vulnerable. The existing web of Soviet-made radar systems and air defenses had grown too sophisticated. The old ways of doing things, flying high, flying low, flying fast, weren't enough anymore. They didn't need a better plane, they needed a whole new idea. They needed a ghost. The problem of the 1980s was a sky full of electronic eyes. Imagine the border of the Soviet Union or its allies not as a line on a map, but as a dense, overlapping forest of radar beams. It's a 3D web of detection, stretching from the ground up to the edge of space. For decades, the game was to find a way through this forest. The first philosophy was to fly above it. This was the SR-71's trick. Go so high and so fast that by the time the forest even knows you're there, you're long gone. It worked, but it was a specialized solution for taking pictures, not for carrying a heavy bomb load. The second philosophy was to fly under it. This was the path taken by bombers like the B-1 Lancer. Hug the ground, flying just a few hundred feet up, using the curvature of the Earth and the clutter of hills and valleys to hide from the big, long-range radar dishes. This was called terrain masking, and it was a white-knuckle ride for the pilots. The problem was the Soviets developed a counter, look-down, shoot-down radar. They put powerful radars on their own interceptor jets, like the MiG-31, which could fly high above and scan the ground below, picking out the low-flying intruders from the terrain. The floor was no longer safe. So if you can't go over it and you can't go under it, what's left? You have to go through it. But you have to do it in a way that the forest of radar never even knows you're there. You have to become invisible. This is where the story takes a turn into the world of black projects. These are programs funded by budgets so secret they don't officially exist. They live in a world of code names, secure facilities, and engineers who can't tell their families what they do. In the late 1970s, in these deep black corners of the defense world, a radical new idea was taking shape based on the obscure work of a Russian physicist. The physicist was Pyotr Umfintsev. In the 1960s, he published a number of papers on predicting how radio waves reflect off two-dimensional and three-dimensional shapes. His work was highly theoretical, and the Soviet Union saw little practical military value in it, so they let it be published openly. Big mistake. Across the ocean, engineers at Lockheed's Skunk Works got their hands on translations of his papers. They realized Umfintsev had, without knowing it, written the mathematical recipe for invisibility. He had created the formula for a ghost. Umfintsev's work, which the Soviets had dismissed as academic noodling, was the key. His equations showed that the relativity of an object to radar has almost nothing to do with its size and everything to do with its shape, especially the shape of its edges. A large flat plate, angled correctly, could reflect less radar energy than a tiny, complexly shaped metal sphere. Suddenly, the engineers at Skunk Works had a mathematical blueprint. They could design a shape from scratch, not for aerodynamic performance, but for the sole purpose of making radar waves get lost. This led to a top-secret prototype program codenamed Have Blue. The result was one of the strangest flying machines ever built. It looked like a faceted diamond, a collection of flat panels tilted at very specific, carefully calculated angles. It was nicknamed the Hopeless Diamond by its creators because it was so aerodynamically unstable it looked like it shouldn't be able to fly at all. And without a computer making constant corrections, it couldn't. But fly it did. And its performance against radar was miraculous. In tests, the Have Blue prototype, a jet the size of a fighter, had a radar cross-section, the technical term for how visible something is to radar, that was reportedly the size of a marble. It worked. The theory was sound. An aircraft could be made effectively invisible. With this proof of concept in hand, the real project could begin. The Advanced Technology Bomber, or ATB competition, was launched in total secrecy. The goal was to take the principles learned from the tiny Have Blue demonstrator and scale them up into a full-size intercontinental heavy bomber. The contract was fiercely contested, but it was ultimately won by Northrop, a company whose founder, Jack Northrop, had been obsessed with a very specific and unusual aircraft design for his entire life. Jack Northrop believed with an almost religious fervor in the flying wing. He argued for decades that a plane with no tail and no distinct fuselage was the most efficient and elegant form of flight possible. He built several flying wing prototypes in the 1940s, like the YB-35 and the jet-powered YB-49. They were beautiful, futuristic machines, but they were plagued by instability problems, and the Air Force ultimately rejected the concept. The failure reportedly broke Northrop's heart. Now, decades later, his company had won the contract to build the most advanced bomber in history. And the design they had settled on, the only design that could truly meet the demanding stealth requirements, was a perfect, pure, flying wing. It was the ultimate vindication of Jack's longtime dream, a dream that was about to be realized with a budget that would make a pharaoh blush.
So let's go back to that rollout ceremony in 1988. The first thing that strikes you about the B-2 is that shape, that impossible tailless boomerang. And the reason it looks like that is entirely down to the physics of hiding. First, the obvious. There is no tail. A vertical tail fin is a fantastic feature if you want your plane to be stable and fly in a straight line. It is also a fantastic feature if you want to be seen by radar. A flat, vertical surface is a perfect radar reflector. It's like holding up a giant mirror to a searchlight. By eliminating the tail entirely, Northrop's designers removed one of the biggest sources of radar reflection on a conventional aircraft. Of course, this also made the plane want to tumble out of the sky, but we'll get to the computer magic that solves that little problem later. Second, there are no right angles. Look at a B-2 from any perspective. You will not find a single 90-degree corner. Every surface flows smoothly into the next. This principle is called continuous curvature. A hard corner where a wing meets a fuselage, for example, creates a little canyon where radar waves can bounce around and then shoot right back to the receiver. The B-2's blended organic shape is designed to prevent this. It gently scatters radar energy in all directions, like a smooth, oddly shaped rock in a stream, rather than reflecting it back like a dam. The leading edge of the wing is a sharp, saw-toothed line. This isn't for style. The angle of that sweep and the serrated pattern are precisely calculated to take incoming radar waves from the front and deflect them harmlessly away to the sides, far away from the radar detector. The same is true for the beak at the nose. Every line on this aircraft is a carefully crafted piece of a mathematical puzzle, designed to make the plane a black hole for radio waves. Even the surface itself isn't simple. The skin of the B-2 is made from advanced carbon graphite composite materials, which are inherently less reflective than metal. And on top of that is a top-secret coating of radar absorbent material, or RAM. This isn't just paint. It's a complex, often rubbery substance filled with tiny particles like microscopic iron spheres that are designed to physically absorb radar energy and convert it into a tiny amount of heat. The B-2 doesn't just deflect radar, it eats it. The result of all this is a bomber the size of a 757 that on a radar screen looks about the size of a bumblebee.
Hiding from radar is one thing, but radar isn't the only way to find a plane. You also have to hide from heat-seeking missiles. And jet engines are, fundamentally, very hot things. This is where the B-2's design goes from merely clever to obsessively paranoid. The four engines are not slung under the wings in pods like in a normal plane. They are buried deep inside the thickest part of the wing. If you look at a B-2 from below, you can't see the engines at all. The engine intakes are on the top of the wing, not the bottom. This brilliant piece of design means that ground-based radar and infrared sensors have no direct line of sight to the spinning, highly reflective turbine blades of the engine compressors, a major source of radar return on a conventional jet. But the real magic is at the other end, the exhaust. On a normal plane, you get a roaring circular plume of superheated gas. A heat-seeking missile would see this as a giant glowing "eat here" sign. The B-2's exhaust system is completely different. The hot gases are first mixed with cool air drawn in from the boundary layer over the wing. Then, instead of being blasted out of a round nozzle, they are channeled through long, flat, trough-like troughs on the upper surface of the aircraft. This design does two things. First, it allows the hot exhaust to cool significantly before it leaves the plane. Second, the flat shape and the shielding provided by the wing itself prevent ground-based infrared sensors from ever getting a clean look at the heat source. By the time the exhaust gases drift out from behind the aircraft, they are cool enough to blend in with the background atmosphere. The B-2 was designed to be as thermally invisible as it is radio invisible. But the designer's paranoia didn't stop there. One of the easiest ways to spot a high-flying aircraft on a clear day is the contrail, the long white line of condensed water vapor that streams from the engines. A contrail is a giant arrow in the sky, pointing directly at your secret bomber. So the B-2 is equipped with a special system to deal with this. A sensor detects the specific temperature and humidity conditions where contrails are likely to form. When these conditions are met, a chemical, rumored to be chlorofluorosulfonic acid, is injected into the exhaust stream. This chemical mixes with the water vapor and prevents it from forming the visible ice crystals of a contrail. The ghost can erase its own footprints in the sky. So you have a tailless, continuously curved, radar-absorbing, heat-suppressing, contrail-killing boomerang. But all of these design choices for stealth create a massive aerodynamic problem. The B-2 is, to put it politely, a pig to fly. Or rather, it would be if a human were actually flying it. A flying wing with no vertical tail is naturally unstable. It has a tendency to yaw or fishtail from side to side. In the 1940s, Jack Northrop's original flying wings were a nightmare for pilots because they required constant, minute corrections to keep them flying straight. In the 1980s, the solution was computers, lots of them. This is the secret heart of the B-2. It is not truly flown by the pilot. It's flown by a quadruply redundant digital fly-by-wire system. The pilot's controls, the stick and throttle, are not physically connected to the aircraft's control surfaces. They are simply inputs or polite suggestions to the flight control computers. The pilot says, "I would like to go this way," and the computer says, "Thank you for your input. I will now perform the 1 million calculations per second required to make that happen without the aircraft tumbling into a flat spin." To control its direction, the B-2 uses a series of flaps and air brakes along the trailing edge of the wing called elevons. To turn left, for example, the computer will raise a flap on the left wing and create a tiny amount of drag pulling the nose to the left. But this action also wants to make the plane roll and pitch, so the computer simultaneously makes dozens of other tiny adjustments to other flaps to counteract those motions. It is a constant, invisible, high-speed balancing act. The pilots are not so much flying as they are aiming. They are mission commanders guiding the incredibly smart computer that is actually keeping this impossible shape in the air. This reliance on computers created a whole new set of challenges. The software for the B-2's flight control system was one of the most complex and expensive parts of the entire program. It had to be perfect. A single software bug, a single flawed line of code could be catastrophic. The entire aircraft, with its $2 billion price tag, is utterly dependent on the smooth functioning of a ghost in the machine, a digital brain that translates a pilot's simple request into a symphony of subtle aerodynamic adjustments.
Building a plane this complex and this sensitive means you can't just park it outside next to the other jets. The B-2 isn't just an aircraft. It's a delicate, high-maintenance diva. And a diva needs her own special dressing room. This brings us to the hangars. After the B-2 program became public, people started noticing strange new buildings being constructed at Whiteman Air Force Base in Missouri, the B-2's only operational home. These were not your typical aircraft shelters. These were massive, climate-controlled facilities, often referred to as docks. Each B-2 has its own private air-conditioned home. Why? Because the B-2's invisibility depends entirely on the perfection of its skin. The radar-absorbent materials and stealth coatings are notoriously sensitive to the elements. Rain, humidity, ice, and even direct sunlight can degrade their effectiveness. A B-2 left out in the rain is, electronically speaking, getting sick. So to preserve its low absorbent characteristics, the aircraft must be kept in a controlled environment, a giant, taxpayer-funded humidor. Inside these hangars, the maintenance is a painstaking, almost religious ritual. The B-2 has no traditional access panels or doors. To get to the engines or other internal systems, maintenance crews have to carefully peel back sections of the radar-absorbent tape and coatings. After the work is done, they have to reapply those coatings and seal every seam with a special putty. This process is slow, expensive, and has to be done with absolute precision. A single sloppy seal or a screw that isn't perfectly flush can create a hot spot that will light up on an enemy radar screen like a Christmas tree. Technicians use specialized tools to measure the conductivity and reflectivity of the skin, constantly checking for flaws. It's less like aircraft maintenance and more like caring for a giant temperamental piece of high-tech sculpture. The popular joke among maintainers is that you don't park a B-2, you curate it. This incredible need for specialized care is a huge part of the aircraft's astronomical operating cost. It's not just the price of the plane itself, it's the price of the billion-dollar garage and the team of artists required to keep it looking and functioning like a featureless black hole.
So, who operates this $2 billion ghost? Unlike the bombers of old, with their crews of 5, 6, or even more, the B-2 is run by a crew of just 2. A pilot, who's also the mission commander, and a co-pilot. That's it. 2 people, locked in a small bubble at the front of this massive wing for missions that can be almost unimaginably long. The cockpit of the B-2 is surprisingly spacious, but it's designed for endurance, not comfort. Behind the 2 main ejection seats, there is a small flat space about 6 feet long. In this space, there is a rudimentary toilet, a small microwave oven for heating prepackaged meals, and enough room for one crew member to lay out a sleeping bag on the floor while the other flies the plane. This is their home for missions that can last 30, 40, even 50 hours. A typical B-2 mission doesn't involve flying to a forward base in another country. The whole point of the B-2 is its immense range. It can take off from its climate-controlled garage in Missouri, fly halfway around the world, drop its bombs, and fly all the way back home without ever landing. This creates missions of incredible duration, demanding a level of human endurance that pushes the limits. The 2 pilots trade off duties. One might fly for a 6-hour shift while the other attempts to sleep on the floor, just feet away from the humming electronics and the faint roar of the engines. They are completely isolated, a 2-person society hurtling through the stratosphere. They have to be pilots, navigators, weapons officers, and sometimes even their own flight surgeons, all while managing the fatigue and mental strain of a flight that can last for 2 full days. This endurance requirement is one of the most challenging aspects of the B-2 program. The Air Force has invested heavily in studying fatigue management, crew scheduling, and even specialized pharmaceuticals to help the pilots stay alert. Because on a 44-hour flight to Afghanistan and back, the most critical component, the one most likely to fail, isn't the complex fly-by-wire system or the delicate stealth skin. It's the human brain, the 2 soft, fragile computers that are ultimately in charge of the world's most advanced weapon.
Let's talk about the price, because you can't really understand the B-2 without understanding the money. It is, without any serious competition, the most expensive aircraft ever created. And the numbers are so large they start to lose all meaning. The original plan in the late 1970s was to build a fleet of 132 of these advanced technology bombers. But as the development went on through the 80s, the costs just kept climbing. The complexity of the stealth materials, the groundbreaking computer systems, the sheer amount of research and development required for every single component, it all added up. At the same time, the world was changing. In the late 1980s, the Soviet Union, the very adversary the B-2 was designed to fight, began to crumble. The Cold War was ending. Suddenly, justifying a fleet of 132 invisible bombers at a cost of hundreds of billions of dollars became politically impossible. Congress started getting very nervous. The program was repeatedly cut, first from 132 down to 75. Then, after the fall of the Berlin Wall, the entire program was under threat. In the end, a final decision was made under the first Bush administration to cap the fleet at just 21 aircraft. This drastic reduction in numbers had a perverse effect on the price per plane. A huge chunk of the program's cost was in the research and development, the R&D,
When you spread that massive R&D cost over 132 planes, the price per plane is high. When you spread that same R&D cost over just 21 planes, the price per plane skyrockets into the absurd. The final flyaway cost for each B-2 was around $737 million in 1997 dollars. But when you factor in the total program cost, all the R&D, the special hangars, the testing, everything, the price per aircraft bloats to an eye-watering $2.13 billion. Yes, billion with a B. Let's try to put that in perspective. The B-2 weighs about 160,000 pounds empty. In the late 1990s, the price of gold was around $300 per ounce. A quick calculation shows that 160,000 pounds of solid gold would have been worth about $768 million. The plane was literally, by a very wide margin, worth more than its weight in gold. You could have built entire fleets of other fighter jets, funded NASA's budget for a year, or solved any number of terrestrial problems for the cost of a handful of these flying wings. It is a weapon so expensive that the decision to even let it take off in bad weather becomes a matter of national financial planning.
With a price tag that high, the B-2 was always going to be a political football. The debate over the B-2 in the early 1990s was fierce, and it gives a fascinating glimpse into the sausage-making of military procurement. On one side, you had the Air Force and Northrop, arguing that the B-2 was an essential tool. They painted it as a silver bullet, a unique capability that would allow the U.S. to hold any target on the planet at risk. They argued that even with the Soviet Union gone, the world was still full of dangerous dictators with increasingly sophisticated air defenses. The B-2, they claimed, was the only thing that could guarantee access to these well-defended areas in the first critical hours of a conflict. It was an insurance policy against the unknown threats of the future. On the other side, you had a powerful group of critics in Congress and the media. They looked at the $2 billion price tag and saw a Cold War relic, a weapon built for a war that was never going to happen. They argued the money could be better spent on more conventional forces or on domestic programs. They derided the B-2 as a Gucci bomber, a gold-plated toy for the Air Force. The most famous critic was Democratic Congressman John Kasich, who famously said, "This is a plane that can't be seen, carrying bombs that can't be afforded." The fight over cutting the fleet from 21 down to 20 was particularly brutal. Northrop and its supporters launched a massive public relations campaign. They ran ads with the tagline, "The B-2, America's Peacemaker," trying to frame the bomber as a tool for stability. They argued that stopping production would mean losing the specialized workforce and tooling, making it impossible to build more in the future if they were needed. In the end, a compromise was reached. The production line was shut down after the 21st aircraft was built, but one of the original test models, a static test airframe that was never meant to fly, was later converted into a fully operational bomber, bringing the final fleet size to 21. The battle was over. The U.S. was left with a tiny handful of the most capable and most expensive bombers ever conceived, a fleet of ghosts born from a dead empire, paid for with a king's ransom, now waiting in their special garages in Missouri for a new kind of war.
For years, the B-2 was a weapon in theory only. It was a deterrent, a $2 billion what-if that sat gleaming in its climate-controlled hangar. But in 1999, the ghost finally went to war. The conflict was in Kosovo. Operation Allied Force was a NATO-led air campaign to stop the ethnic cleansing being carried out by Serbian forces. The Serbian military, supplied for decades by the Soviet Union, had a dense and modern integrated air defense system. It was a dangerous place to fly. This was the exact scenario the B-2 was built for, kicking down the door of a well-defended adversary on the first night of the war. The missions began at Whiteman Air Force Base in Missouri. The B-2s would take off, climb into the night sky, and begin the long, 15-hour flight across the Atlantic. They would meet up with tankers for fuel, cross over Europe, and then descend into Serbian airspace. And they were completely undetected. The Serbian radar network, which was actively tracking other NATO aircraft, saw nothing. There were no warnings, there were no interceptors scrambled. The B-2s would fly to their pre-assigned targets, airfields, command bunkers, communications nodes, and open their bomb bay doors. The B-2 has a rotary launcher inside, like a giant revolver. It can carry up to 8,500-pound GPS-guided bombs, known as JDAMs. The bombs would be released, and the B-2, its work done, would simply turn around and begin the long flight back home to Missouri. A single mission was a 30-hour round trip. The pilots would land, debrief, and hand the jet over to the ground crew, having fought a war and returned home without ever setting foot on foreign soil. The impact was devastating and decisive. The B-2s destroyed 33% of all Serbian targets in the first 8 weeks of the war, despite flying only a tiny fraction of the total sorties. They proved that the theory worked. A tiny fleet of invisible bombers, operating from the safety of the American heartland, could systematically dismantle an enemy's defenses with impunity. The Ghost had shown its teeth, and it proved to be every bit as effective as its creators had promised. The era of stealth warfare had truly begun.
The success in Kosovo cemented the B-2's role in the U.S. military. It wasn't a strategic bomber in the old sense, like the B-52, designed to carpet bomb large areas. It was a scalpel. It was a first night weapon, a tool for surgical strikes against the most critical and heavily defended targets. It became known as a door kicker. Imagine you need to get into a locked house. You could spend hours trying to pick the lock, or you could use a battering ram to smash the door off its hinges. The B-2 is the battering ram. In the opening hours of a conflict, the B-2s are sent in first, alone, into the darkness. Their job is to take out the enemy's eyes and ears. They target the key command and control bunkers, the long-range radar installations, the surface-to-air missile sites, and the enemy airfields. By crippling these key nodes, the B-2 effectively blinds and deafens the enemy, creating safe corridors in the sky. Once the door has been kicked down and the corridors are open, the rest of the Air Force, the non-stealthy or visible assets like F-16s, F-15s, and B-1s, can pour in and operate with much lower risk. The B-2 doesn't win the war by itself, it makes it possible for the rest of the military to win the war. This role was demonstrated again in the opening nights of the wars in both Afghanistan and Iraq. B-2s once again flying non-stop from Missouri were among the very first strikes of the conflicts. One of the most remarkable missions was a 44.3-hour combat sortie during Operation Enduring Freedom in Afghanistan, the longest combat flight in aviation history. A B-2 crew flew from Missouri, hit their targets in Afghanistan, and recovered at a forward base in Diego Garcia in the Indian Ocean, swapped out with a fresh crew, and the plane was readied for another mission. This global reach is the B-2's other superpower. With aerial refueling, its range is limited only by the endurance of its two-person crew. The fact that the entire fleet is based at a single, highly secure base in the middle of the United States means it is safe from surprise attack. But from that single base, it can project power anywhere on the planet within 48 hours.
It is a dagger held in the dark, ready to strike any target, anywhere, at any time.
So, the B-2 is a ghost that kicks down doors. But what exactly is it kicking with? The payload of the B-2 is held entirely within its belly, in two massive bomb bays. And the delivery mechanism isn't just a simple rack that drops bombs. It's a testament to the over-engineering that defines this entire aircraft. Inside the bomb bay is a device called the Rotary Launcher Assembly, or RLA. Imagine a gigantic 16-foot-long revolver cylinder lying on its side. This launcher can be preloaded with various types of munitions, and when it's time to strike, it rotates to bring each weapon into the release position. This system allows for incredible flexibility. On a single pass, a B-2 can drop up to 80 individual 500-pound GPS-guided bombs, each one capable of hitting a separate target. It can turn a single airfield into 80 precisely placed craters in a matter of seconds. But it's not just about quantity. The B-2 is also the designated carrier for some of the most specialized and powerful conventional weapons in the U.S. arsenal. Its most terrifying non-nuclear payload is a bomb called the GBU-57, Massive Ordnance Penetrator, or MOP. Calling this thing a bomb is an understatement. It's a 30,000-pound monster, a telephone pole-sized behemoth designed for one purpose: to destroy the most deeply buried and hardened enemy bunkers. The MOP is so enormous and so heavy that no other aircraft in the inventory can effectively carry and deploy it. The B-2 can carry 2 of them, one in each bomb bay. The concept is simple. The B-2 flies high over the target, releases the MOP, and the bomb, guided by GPS, uses its immense weight and kinetic energy to pierce through up to 200 feet of earth or 60 feet of reinforced concrete before its warhead detonates. It is a weapon designed to kill targets that believe they are untouchable, buried deep under mountains or beneath layers of steel and concrete. This capability is central to the B-2's modern role. It is America's bunker buster. When a hostile nation builds a secret nuclear facility deep underground, the B-2, armed with the MOP, is the implicit threat. It's the only tool that can reliably reach out and touch that target. This makes the B-2 more than just a bomber. It's a strategic message. It's a quiet reminder to would-be adversaries that no matter how deep you dig, no matter how much concrete you pour, the ghost can still get you. The B-2's most effective weapon might not be the bombs in its belly, but the very idea of its existence. Its primary function in peacetime is psychological. It is a ghost story that the Pentagon tells to its enemies, and the scary part is that the story is real. Imagine you are a military commander in a hostile nation. You have spent billions on an advanced integrated air defense system. You have the best radars, the best surface-to-air missiles, the best interceptor pilots. You believe your airspace is a fortress, but you know the B-2 exists, and because of that, you can never, ever be sure that you are safe. Every single moment of every single day, you have to operate under the assumption that a completely undetectable $2 billion bomber could be flying 50,000 feet directly over your head, not just over your country, but over your command bunker, over your home. You have no way of knowing. It creates a unique and corrosive kind of paranoia. Is that faint glitch on the radar screen just atmospheric clutter, or is it a B-2? Was that communications blackout a technical fault, or did a ghost just vaporize a key relay station 100 miles away? This is the B-2's true power as a deterrent. It injects crippling uncertainty into an enemy's entire decision-making process. It forces them to spend vast sums of money on countermeasures that probably won't work. It makes them question their own intelligence and the integrity of their defenses. It is, in essence, a weapon of gaslighting. The Air Force is keenly aware of this. They don't hide the B-2 anymore. They strategically release high-quality photos and videos of it. They have it perform dramatic flyovers at Super Bowls. This isn't just patriotic pageantry, it's a calculated display. It's the monster deliberately showing its shadow to remind everyone that it's still out there. Every public appearance is a carefully managed piece of global psychological operations. For the 21 nations that currently operate the B-2, its presence is a silent, constant source of anxiety for their potential foes. They don't have to use it for it to be effective. The Ghost's mere presence in the global inventory is enough to keep people up at night. And in the world of geopolitics, a sleepless enemy is a less dangerous one.
For a weapon system shrouded in so much secrecy, a ghost designed to be invisible, the B-2 fleet has a surprisingly public and personable side. Every one of the 21 aircraft has its own name. It's a tradition that feels oddly wholesome for a $2 billion death machine. The first operational B-2 was christened the Spirit of Missouri in honor of the state where its home base is located. The rest of the fleet followed suit, each one being named Spirit of a particular U.S. state. You have the Spirit of California, the Spirit of New York, the Spirit of Kitty Hawk, an honorary title, and so on. The naming ceremonies are formal affairs, with governors and senators often in attendance to christen their state's bomber. This is, of course, brilliant public relations. It gives the aircraft a sense of identity and connection to the American people who paid for it. It's much harder for a politician to vote against funding for the Spirit of Ohio than it is to cut an item line called ATB Production Lot 3. It transforms an abstract, terrifyingly expensive piece of military hardware into a local point of pride. It's a soft power move played on the domestic audience. There's also a dark irony to it. Naming these machines after places like New York or Arizona or Pennsylvania gives them a friendly, almost neighborly quality. It masks the reality of what they are, arguably the most destructive conventional weapons platforms ever devised. There was a profound disconnect between the heartland-friendly name Spirit of Indiana and the image of that same aircraft unleashing 8,500-pound bombs on a target halfway across the world. The pilots and ground crews develop a real attachment to their specific aircraft. They don't just work on a B-2, they work on the Spirit of Washington or the Spirit of Louisiana. It fosters a sense of ownership and esprit de corps, but it's a strange thing to humanize a machine whose sole purpose is to be an inhuman, untouchable phantom. It's one of the many contradictions of the B-2. It is at once a nameless, featureless ghost to its enemies, and the beloved, personally named Spirit of South Carolina to the men and women who fly and maintain it.
Even a $2 billion aircraft maintained in a climate-controlled palace and curated by an army of technicians can have a very, very bad day. For 19 years, the B-2 fleet had a perfect safety record. But on February 23, 2008, that record came to a dramatic and expensive end. The setting was Andersen Air Force Base in Guam. The B-2 Spirit of Kansas was taking off for a return flight to Missouri after a 4-month deployment. The 2-person crew began their takeoff roll as normal, but as the aircraft lifted off the runway, it suddenly and violently yawed to the left.
The pilot fought for control, but the left wingtip scraped along the runway and the aircraft began to stall. With no altitude and no hope of recovery, both pilots ejected safely. The Spirit of Kansas, the ghost that was supposed to be untouchable, tumbled into the grass next to the runway and erupted into a massive fireball. The crash of the world's most expensive airplane was, thankfully, captured on video, providing investigators with a wealth of data. The investigation revealed a surprisingly mundane cause for such a spectacular failure. It wasn't a major engine failure or a catastrophic structural problem. It was water. Specifically, moisture. During its deployment in the hot, humid climate of Guam, condensation had gotten into 3 of the aircraft's 24 air data sensors. These sensors, known as port transducers, are responsible for measuring critical information like airspeed, altitude, and air density. This raw data is fed to the flight control computers, the digital brain that actually flies the plane. Because of the moisture, the sensors were feeding bad data to the brain. The computer was getting conflicting and incorrect information about its own speed and angle of attack. Essentially, the aircraft thought it was flying under a different set of conditions than it actually was. When the wheels lifted off, the flight control computer, acting on this faulty data, gave an incorrect command to the control surfaces, commanding a sudden and unrecoverable pitch-up maneuver. The pilots never stood a chance. The plane was doomed by a few drops of water in the wrong place. The crash was a stark reminder of just how much the B-2 relies on its complex nervous system. It is a machine so advanced and so aerodynamically unstable that it is completely at the mercy of the data it receives. A single bad signal can be fatal. And it was a $2 billion lesson in the importance of keeping your sensors dry.
The B-2 was designed in the 1970s and built in the 1990s. In the world of high technology, that makes it ancient. A normal aircraft from that era would be long retired or relegated to secondary duties. Yet the B-2 remains the absolute tip of the spear for American air power. How is a 30-year-old design still a frontline asset? The answer is upgrades. Constant, eye-wateringly expensive upgrades. Keeping a ghost relevant is not cheap. The B-2 fleet has been in a state of near continuous modernization since the day it was delivered. The first major upgrade involved the stealth coating itself. The original radar-absorbent material was incredibly effective, but also incredibly fragile and time-consuming to maintain. In the 2000s, the Air Force began a program to replace the original coating with a new, more durable material. This new alternate high-frequency material reportedly offered the same stealth performance, but significantly cut down on the man-hours required for repairs. The Diva's backstage demands were lessened, but only slightly. The computers and software have also been replaced multiple times. The original processors from the 1980s, which were cutting-edge at the time, are hopelessly outmatched by modern computing. The entire avionics suite has been ripped out and replaced with faster processors, more memory, and new architecture. This allows the B-2 to use newer, smarter weapons and to better integrate into the modern, networked battlefield. Communications gear has been another focus. The B-2 was originally designed for a lonely, solo flight into the Soviet Union. Today, it needs to be able to communicate in real time with satellites, drones, and other friendly forces. This required the installation of new, high-bandwidth satellite communication links. The challenge was adding these new antennas without compromising the aircraft's carefully tuned stealth profile. Every new bump or antenna has to be specially shaped and coated to remain invisible. These upgrades ensure the B-2 can still kick down the door against the most modern air defenses in the world. But they also mean that the $2 billion price tag was just the down payment.
The cost of continuously modernizing this tiny fleet of 20 aircraft is a major line item in the defense budget every single year. It's the price you pay for keeping a 30-year-old ghost at the top of its game.
For 3 decades, the B-2 has been the undisputed king of stealth. But time, and more importantly, budgets, move on. The Ghost is about to have a grandchild. This is the story of the B-21 Raider, the aircraft designed to be the B-2's replacement, and in many ways, its apology. The B-21 Raider is the result of the Air Force looking at the B-2 program and saying, okay, that was amazing, let's do it again, but this time let's try not to bankrupt ourselves. The primary driver behind the B-21 is not necessarily better performance, but affordability and sustainability. The B-2, for all its capability, is a maintenance queen. It's a thoroughbred racehorse that needs constant, expensive pampering. The B-21 is being designed from the ground up to be more like a workhorse. Visually, it looks like a smaller, sleeker, updated version of the B-2. It's still a flying wing, proving that Jack Northrop's original vision is still the undisputed best answer for all aspect stealth. But the details are refined. The engine intakes are even more blended into the wing. The overall shape is simpler, which likely means it's easier and cheaper to manufacture. It's Stealth Bomber 2.0, taking all the lessons learned from the original and applying them. One of the biggest lessons was in the stealth coatings. The B-21 will reportedly use a new generation of radar-absorbent materials that are far more durable and less sensitive to the elements than the B-2's notoriously fragile skin. The goal is to have an aircraft that doesn't need its own private, climate-controlled palace to live in. It's designed to be operated more like a conventional aircraft, drastically cutting down on the maintenance time and cost that makes the B-2 so expensive to fly. The plan is to build at least 100 B-21s, a fleet 5 times the size of the B-2 force, for a fraction of the total program cost. It's a pragmatic evolution. The B-2 was a revolutionary leap into the unknown. A cost is no object pursuit of perfection. The B-21 is the result of that knowledge, a more practical and sustainable application of the same ghostly principles. The Raider's arrival on the scene marks the beginning of the end for the B-2's reign. The king is not being overthrown, he is simply and very expensively abdicating in favor of his more sensible son.
So, as the B-21 Raider slowly enters service over the next decade, what happens to the existing fleet of 20 B-2s? A $2 billion airplane is not something you just send to the boneyard and crush for scrap. The retirement of the B-2 will be a long, slow, and carefully managed process. Unlike a fighter jet that might be retired and immediately put into storage, the B-2s possess a unique capability that the Air Force will be reluctant to give up completely until the B-21 fleet is fully mature and operational. The initial plan is for a gradual phase-out. As new B-21s are delivered, B-2s will be slowly taken off the frontline roster. In their twilight years, the B-2s will likely transition into new roles. Some may become dedicated test and training aircraft. They provide an invaluable platform for developing the next generation of stealth technology, weapons, and tactics. A new sensor or coating can be tested on a B-2 before it's ever installed on a B-21. They can also be used to train new bomber pilots, giving them experience on a large flying wing before they transition to the Raider. There is also a strong possibility that a handful of B-2s will be kept in a state of Type 1000 storage. This isn't just parking them in the desert. It's a meticulous process where the aircraft is cocooned in a controlled environment, its systems preserved, ready to be reactivated if a major global conflict erupts, and every possible long-range bomber is needed. The cost of keeping them in this living storage would be immense, but the cost of building a new one from scratch would be even higher. Ultimately, however, the fleet will be retired. The airframes are already decades old, and the cost of maintaining them will only increase as they age. One by one, they will make their final flights. Some will likely be quietly dismantled, their top-secret composite materials and onboard systems securely destroyed. But a few, like the SR-31s before them, will be carefully demilitarized and prepared for delivery to museums. One day, the Spirit of Missouri or the Spirit of Ohio will become a static display, a silent giant for future generations to stare at, the final resting place for the most expensive ghost story ever told.
The B-2 is more than just a weapon. It's a piece of modern mythology. Its stark, alien appearance has made it a star in its own right, the go-to symbol in pop culture for ultimate futuristic military power. Its shape is so inherently sci-fi that it has been a natural fit for Hollywood blockbusters. One of its most memorable, if brief, appearances was in the 1996 film Independence Day. In the movie's climax, the B-2 is seen taking off, armed with a nuclear missile, part of the desperate final assault against the alien mothership. It's a perfect piece of casting. When humanity is facing an existential threat from the stars, they turn to their most starship-like weapon. A year later, it played a more central role in the action film Broken Arrow, where a rogue pilot steals a B-2 carrying 2 nuclear weapons. The film is filled with dramatic, if highly unrealistic, sequences of the B-2 maneuvering like a fighter jet. While aviation enthusiasts might cringe at the physics-defying flight scenes, the movie cemented the B-2's image in the public consciousness as a sleek, top-secret superplane. This cultural footprint is important. It transforms the aircraft from a dry, budgetary line item into a character. The B-2 represents a certain kind of American technological prowess, mysterious, overwhelmingly powerful, and visually stunning. It's the real-life version of the Batwing. It has come to symbolize the very concept of a black project, a physical manifestation of the secrets happening just beyond public view. Even its presence at public events like the Rose Bowl or the Super Bowl is a form of theater. The flyover of a B-2 is fundamentally different from that of a group of fighter jets like the Blue Angels. The fighters are loud, fast, and exciting. The B-2 is silent, slow, and deeply unsettling. It doesn't scream past the stadium, it glides over it, a giant black shadow that seems to absorb the sound of the crowd. The effect is one of awe and a little bit of menace. It's a quiet, powerful reminder of the invisible world that exists alongside our own, a world of ghosts and unimaginable power.
For an aircraft designed to be invincible, a ghost that can penetrate any air defense system on Earth, the B-2 has a rather ironic and mundane weakness. It is terrified of thunderstorms. Pilots flying the B-2 are under strict instructions to give thunderstorms a very, very wide berth. This isn't just a matter of standard aviation safety. It's about protecting the aircraft's $2 billion superpower, its stealth. The B-2's skin is a delicate, complex tapestry of radar-absorbent materials, coatings, and precisely sealed panels. A lightning strike could wreak havoc on this system. The immense electrical charge could fry sensitive onboard electronics and, more importantly, could burn or blow off sections of the stealth coating, creating a massive hotspot for radar to see. A single bolt of lightning could theoretically turn an invisible bomber into a very visible one. But the bigger concern is turbulence and hail. The B-2 as a flying wing behaves very differently in rough air than a conventional tube and wing aircraft. It has a tendency to flex and undulate. Severe turbulence could put immense stress on the airframe, and hail is the ultimate enemy of the B-2's delicate skin. The impact of hailstones at high speed could pit, damage, and strip away the radar-absorbent material, effectively sandblasting the invisibility right off the plane. A B-2 that is flown through a hailstorm would require millions of dollars and weeks, if not months, of painstaking repairs to its stealth surfaces. This weather-averse nature is one of the great ironies of the B-2. Here is a machine built to operate alone in the most hostile enemy airspace imaginable, a machine that laughs at the world's most advanced missiles, and yet it has to plan its missions carefully to avoid a common cumulonimbus cloud. It's a powerful reminder that for all our technological hubris, nature is still the ultimate boss. The ghost that fears no evil must still divert its path for fear of a little rain and ice.
While the B-2's permanent home is Whiteman Air Force Base in Missouri, the Ghost is a world traveler. To maintain its global reach and to send clear strategic messages, the Air Force regularly deploys small detachments of B-2s to forward operating bases around the globe. These deployments are major undertakings. You can't just fly a B-2 to any old airfield. The destination base needs to have the specialized, climate-controlled hangars ready to house the aircraft. A team of specialist maintenance personnel and a stockpile of the unique materials needed to service the stealth coatings must be sent ahead. It's like a rock band going on tour, but instead of roadies and guitars, it's security teams and radar-absorbent putty. One of the most important forward locations for the B-2 is RAF Fairford in the United Kingdom. Deployments to Fairford allow the B-2s to operate more efficiently over Europe, Africa, and the Middle East, reducing the marathon flight times from Missouri. When B-2s appear at Fairford, it is often seen by international observers as a signal of U.S. intent, a subtle raising of the military posture in the region. Another key location is Anderson Air Force Base in Guam, the very place where the Spirit of Kansas was lost. Operating from Guam positions the B-2 fleet for missions across the vast expanse of the Pacific Ocean. It sends a powerful message to nations like China and North Korea. More recently, B-2s have even made temporary deployments to places as unexpected as Iceland. A deployment to Keflavik Air Base in 2019 was the first of its kind, allowing the crews to train in the challenging Arctic environment and demonstrating the B-2's ability to operate from the high north. Each of these deployments is a massive logistical exercise that costs millions of dollars, but they serve a vital purpose. They acclimatize crews to operating in different parts of the world. They test the Air Force's ability to support a B-2 detachment far from home. And most importantly, they act as a powerful tool of diplomacy and deterrence. The quiet arrival of 3 or 4 black wings at a foreign airfield is a message in itself, a physical manifestation of American power and reach, a ghost making a house call.
We've talked about the machine, the mission, and the money, but what does it actually feel like to fly a B-2? According to the pilots who have done it, the experience is strange. It's less like flying and more like managing a very complex, very quiet, and very expensive computer system. The first thing pilots notice is the silence. The engines are buried so deep inside the wing, and the cockpit is so far forward that the characteristic roar of a jet engine is almost absent. It's a low, deep hum, more felt than heard. There is no violent G-force on takeoff, just a smooth, inexorable push as the massive wing gathers speed and lifts gracefully into the air. The second thing is the smoothness of the ride. Because it's a single, massive wing, the B-2 doesn't bounce and shudder in turbulence the way a conventional aircraft does. Pilots describe it as surfing on the air, flexing and gliding through disturbances. It is an exceptionally stable platform, thanks entirely to the constant, invisible work of the flight control computers. This leads to the third and most profound sensation, a feeling of detachment. The pilot's inputs are not direct commands. There is a sense of disconnection from the machine. You are not flying in the traditional visceral sense. You are overseeing. You are a systems manager. Your job is to monitor the health of the aircraft, to manage the long-range navigation, and to interface with the weapon systems. The raw, seat-of-the-pants act of flying has been subcontracted to the silicon brain in the electronics bay. On a long-duration mission, this sense of detachment becomes even more pronounced. For hours on end, the aircraft will be on autopilot, flying a pre-programmed route through the stratosphere. The pilots are there to watch, to wait, and to be ready to act when the critical moments of the mission arrive. It's a job that requires immense patience and mental discipline. It's hours of serene, quiet boredom, punctuated by moments of extreme, high-stakes focus. It's the life of a ghost's caretaker.
The B-2 was not the first stealth aircraft. That honor belongs to its strange, angular older brother, the F-117 Nighthawk. Looking at the two planes side by side reveals two very different answers to the same question. How do you build an invisible airplane? The F-117, developed in the late 1970s, was the direct result of the Have Blue prototype. It was designed at a time when computers were not yet powerful enough to model the radar returns from complex, curved surfaces. So, the Skunk Works engineers went with what they could calculate: flat panels. The F-117 is a collection of flat, triangular shapes, a faceted gem designed to bounce radar waves away like a disco ball. It was nicknamed the Wobblin' Goblin and was notoriously difficult to fly. It was a brilliant but brute force solution. It answered the stealth question with geometry. The B-2, designed a few years later, represents a much more advanced philosophy. By the mid-1980s, supercomputer technology had evolved to the point where Northrop's engineers could model and predict the radar returns from complex curved surfaces. This led to the B-2's continuous curvature design. Instead of just deflecting radar waves in a few specific directions like the F-117, the B-2's smooth shape scatters the energy in thousands of directions, dissipating the signal and making it much harder to detect from any angle. The B-2 answered the stealth question with calculus. The F-117 was stealthy primarily against low-frequency radars from the Cold War era. As radar technology evolved, its faceted design became more vulnerable. The B-2's design is inherently more broadband, meaning it is effective against a much wider range of radar frequencies, making it far more survivable in a modern air defense environment. The F-117 was a tactical attack jet, a scalpel for hitting specific targets. The B-2 is a strategic bomber, a sledgehammer capable of carrying 16 times the payload over intercontinental distances. The Nighthawk was the first draft, a revolutionary but limited first step. The Spirit was the polished final essay. It took the basic principle and elevated it into a true world-spanning all-aspect stealth platform. One was a ghost born of clever angles. The other was a ghost born of pure computational power.
So, we end where we began, with a shape that shouldn't exist. A silent, black wing that represents the absolute pinnacle of a certain kind of technological obsession. The B-2 Spirit is a paradox.
It is at once a stunningly beautiful piece of engineering and a terrifyingly effective instrument of destruction. It is a source of national pride and a budgetary black hole that has swallowed hundreds of billions of dollars. For over 3 decades, it has been the ultimate symbol of American power. A weapon so advanced and so expensive that its mere existence has been enough to shape global politics. It was built for a single titanic struggle against a Soviet empire that vanished just as it was being born. Yet, it found a new purpose, a new life, as the global ghost of the 21st century. It became the tool used to kick down the doors in new kinds of wars, a silent messenger that could travel from the heart of America to any point on Earth and deliver its message with pinpoint accuracy. Its name, Spirit, is strangely appropriate. It operates not in the physical world of dogfights and defensive maneuvers, but in the spectral world of radio waves and detection thresholds. It is more of an idea than an airplane. It is the physical manifestation of the idea that with enough money, enough ingenuity, and enough time, you can create a hole in your enemy's perception of reality, a hole in the shape of a wing. Today, as the new B-21 Raider prepares to take its place, the Spirit's time on the front line is coming to an end. Soon it will become what the SR-71 is now, a museum piece, a silent artifact from another age. But the Ghost's legacy will remain. It is written in the declassified documents, in the hushed stories of its pilots, and in the strategic calculus of nations around the world. It is the story of what happens when a nation decides to pursue the impossible. It is the story of the immense, almost unbelievable price that must be paid for the power of perfect, absolute silence.